All right, hi everyone. So I'm Kerstiens. I work at Heroku, specifically on the Heroku Postgres team. So before I get started, a really quick show of hands. Who here uses Postgres already? Awesome. Who doesn't at all? Okay. So hopefully I can convince a few people by the time we're done. Before I dig in, a few quick PSAs. If you're on a Mac, which most people are in the room, check out Postgres.app if you're not already using it. It's just more native. It's nice. It's not brewer ports. It just kind of works like most things on Mac. Another one, if you're into Postgres, Postgres Weekly is a good weekly newsletter. And if you're already running Postgres and it's exposed to the internet and you weren't busy upgrading your database yesterday, please go do that now. Like, leave the talk, go do that. It is the worst vulnerability they've had in 6-7 years now. That includes escalation of privileges, an RCE, and a permanent DDoS to your database if it's publicly facing to the internet. So it's actually pretty bad. Go update if you haven't already.
Was it written in Ruby?
It was actually committed by a guy I'll talk about in a minute, which is quite shocking. So the agenda, I'm going to give you just a brief history of Postgres and the project itself, talk a little bit on developing with Postgres, talk some on how to understand performance. That's usually a black box for most application developers when it comes to working with your database, and a little bit around querying. So on some brief history, first off, it's Postgres or PostgreSQL. It's not Postgre. It's not PostgreQL. This is Tom Lane. So Tom Lane is actually, he created, or in collaboration created TIFF, JPEG, PNG, and is the primary contributor to Postgres. And this is a mail from about 8 years ago where he basically says, this is probably the worst decision we made, renaming the project. So it's been around for a long time, depending on when you count. It's been around since probably 95 is what most people consider its origin. It came out of Ingress, which is what most databases came out of, so it shares the same roots as Oracle. I'm not sure if that's a good or a bad thing. But it's very different in that it's completely community-owned and driven. There is no one person that can ever own Postgres, which puts it in a unique position. So it's not going away. If a company goes bankrupt, it can't be acquired. It's completely community-owned and driven, which I think also contributes a lot to its momentum, which I'll talk about kind of more as we go through here. Really important concept is MVCC in it, multi-version concurrency control. Essentially what this means is as a transaction's happening, other people can be reading from it. So it doesn't take a lock anytime it's writing. Basically, a read can see what was there before, and then as soon as that transaction is committed, it can read. And this does a lot for really kind of at the core of what Postgres believes, how it works, and kind of under the covers. A really high level why Postgres. This is actually a quote I stole from a coworker. It's the Emacs of databases. And I think what he was trying to say here is, myself being a Vim user, is it's a platform which you can build on. And you can add extensions to it. It's very extensible. It's not just a place for storing text and numbers. It's a lot more than that. But if you want a better description of kind of why Postgres, here's kind of the TLDR. We'll cover a lot of these in the talk pretty quickly. But if not, I mean, you can basically just search for these and find a pretty good description. So developing with Postgres. First thing, pSQL, it's your friend. If you don't use it, it's really awesome. It's over here now. So DT will describe tables for you. You can query. /E is awesome. It'll open up in your default editor of choice. I can go in here and edit this. You can set up Sublime or whatever you want as your default editor, and it just works. There's a ton of commands basically in there. \# will give you the list of all the commands. It's basically the help. And it's basically, if you're not using it, you should be as your query editor. So data types, Postgres has a bit of a different approach than most databases to data types. Their data types look like this. So you've got things like the obvious, which is a ton of numeric things and currency and that kind of stuff. But you've also got IP and MAC addresses in there. You've got shapes for very basic geospatial stuff. So you can have 2 points and basically compute the distance between them. Just going to highlight a few really interesting ones that I think are really powerful when you need them and often overlooked. The first is arrays. I assume everyone here has used an array inside your application, right? But how many times have you used one inside your database? Like, why can't they actually be the same thing there? So pretty straightforward. If you've got a blog post or an articles and you have tags, there's really no reason to join that against another table. Just put an array in and put a tag cloud in right there. So pretty straightforward. You insert just like you would expect. There's not a lot of magic science here. It's basically just an array inside your database. Then basically you can query and filter where it contains all of them, where it contains one of them. And the nice thing about actually doing this inside the database is it's going to push down those optimizations for you. Range types are a newer one as of Postgres 9.2. If you've ever done a calendaring application, you've probably had a from and a to. Range types are just that. It's a from and a to. But there's a really nice thing that you can do with them. So basically, you can have a open-ended, the parentheses or the brackets. It's either it starts now or it's this or equal to. So there's the nuances in there pretty easily. So you don't have to necessarily build that up into your application logic. But the really nice thing is if you're trying to, you have a capacity for a class, like the conference or a classroom only has 20 seats and people are registering. By the time you've run the query to see if that's available, you could actually have already inserted and then automatically commit someone else. So you've got 21 people in a room that seats 21 in your application. So with the exclusion constraint on this kind of data type, what you can basically say is, I can only have one talk in this conference room at a time, or I can only have 20 people in this conference room at a time. So I basically added an exclusion constraint right here. It looks kind of crazy. It's not too bad. Insert into that, and then my database is going to raise an error. So you've actually got the enforcement on the data, which is where you care about. But beyond that, you've got the basic data types. Like I said, kind of Postgres is a data platform as much as it is anything. So you've got a ton of extensions in it. And extensions, in 9.4, basically there's going to be an apt-get packaging repository where you can just install an extension from anywhere in the wild. Right now, they kind of come packaged with Postgres. But they really extend a lot of the functionality. So a few specific to data types. I actually had no idea that this was a big issue for a lot of MySQL people, but by default, it's case insensitive. I think as a text when you search. And hearing someone migrate from MySQL to Postgres, they would have loved to know about the CI text type, which is a case insensitive data type. There's cubes for cubing data. There's Hstore, and Hstore is a really awesome one. It is essentially what kind of starts to become NoSQL inside your SQL database. So Hstore, it's as simple as saying create extension Hstore to enable it inside your Postgres database, and then you've got a data type just like any other. And what it is it's a key value store inside your database. Unfortunately, it's only text, but then I can do things like this, where I can say insert sex and state. And it gives you that flexibility that you care about in your data. If you're early stage prototyping, you don't have to run migrations on your database. You can just start adding keys and values in there. We use this pretty heavily in production in places at Heroku, and it's performant, it works well. You can do everything that you would expect to do with it. But like I said, it's text only, and it's key value. You can't nest things, so it's not a full document store. And that's kind of where JSON comes in. So in Postgres 9.2, there's a native JSON data type. It does essentially validation on the data, and that's about it. It doesn't do too much more, so it validates that it's valid JSON, but not too much more. But it actually can get a lot nicer. How many people here have heard of or used PLv8? Okay, that's not nearly enough hands. PLv8 is a V8 JavaScript engine embedded inside Postgres. So it's the exact same thing that's running inside Mongo, that's running inside your Chrome web browser, and you can do things like this. And I'm not sure how quickly anyone can pick up on what this is, but essentially don't do this. JavaScript injection attacks are a bad thing. Now you can do fun things with your data with JavaScript, but don't execute arbitrary JavaScript in your database because SQL injection attacks are bad enough as it is. Beyond that, you've got full text search and Postgres. They could use each their own full half hour. If you've got data and you need text search, full text search is pretty robust. There's a gem that kind of adds it out of the box. And Postgres, there's a broad set of libraries for it. So if you're doing geospatial stuff, it's pretty much the de facto. So performance. Sequential scans. How many people know what a sequential scan and index scan are? Okay. The general idea is, they're usually assumed to be bad. But this is most of the time. If you're doing any data warehousing queries, they're actually pretty okay. That's what you want to be doing. Postgres a lot of times is smarter than you are about your data, and trust it when it does them sometimes. That said, indexes are still usually good, but that's also most of the time. So Postgres has a variety of index types. There's btree, gen, gist, knn, spgist. Usually people just say create index, and that works pretty well. But as soon as you start digging under the covers, it's usually a little bit like this. If you're unsure, you're probably safe. Btree is the default. When you say create index, this is what happens. This is usually what you want, unless you're doing anything unique or crazy. Gen is a generalized inverted index. It's what you want most of the case when you have an array or an Hstore. If you've got multiple values inside the same column, it's essentially what you want. And there are exceptions to that, but you're usually pretty safe if you go with it. Gist is pretty much the de facto for full text search, for shapes, for GIS stuff. So if you're doing anything in that case, that's kind of where you want to look into. KNN is k nearest neighbor, so that's similarity. And spgist, I've had it explained to me 5 times by Postgres people, and I still don't understand it. But I hear it's valuable. So I hear it's valuable for phone numbers, and that's about all I know. So good. If you find out a case for using it, let me know. So that's great, but how do you actually understand performance on your database? So given a really basic query, Postgres has a command called explain. You can run it, and it's going to give you something like this. And I know a lot of people that work with Postgres for a lot of years and still don't understand this. It's really not too bad. I won't say it's too friendly, but it's not too bad. Those numbers out to the right, there's essentially 3 things right there. So there's the startup time for the query, its maximum time that it's going to estimate, and the rows that it expects to return. So if you run explain analyze, explain shows you what it thinks it's going to do. Explain analyze shows it runs the query and shows you what it actually did. So you've got grayed out, what it thought it was going to do, and then you've got the actual time down here. And if you know Postgres well, my stats are off and I hadn't vacuumed my data just because I bulk loaded. But either way, it probably would have still done the same plan in this case. And what it's going to show is the actual time for this is 295 milliseconds. Some rough guidelines for pretty much any web application. This isn't the case for data warehousing and big data reporting, that kind of thing. But web applications, rare queries you want to be under 100 milliseconds, and common queries you want to be under 10 milliseconds. And I would actually say common queries you probably want to be closer to 1 millisecond. Most applications I look at, that's what we aim to get them to, and we're pretty comfortable with that. So obviously, given this, it's doing a sequential scan on employees. It's going to look for salary to be above a certain thing. Adding an index on salary, I'm going to rerun it. It's going to use the index scan like you would expect. And then my total runtime is now going to be 1.7 milliseconds. So a few tips on indexes. If you haven't used create index concurrently, it's probably what you want all the time. When you create an index, it takes a lock on your table, which means you can't write to it while it's building up the index. If you create this concurrently, it's going to be about 2 to 3 times slower, but let you keep writing data to the table. So if you've ever run certain other databases and added an index or added a column and it takes 2 or 3 hours, that doesn't have to be the case with Postgres, or with column addition or with indexes if you do them concurrently. Conditional indexes are great. If you've got like a phone book application, right, and you have every address someone lived at forever, but you only care about the current one, right? You can basically say whether their current address is true, and it's going to index only on that. So you can have all of your data there and index on only a part of it. Queries like this are bad pretty much in all cases. Queries like that are okay. If you have a wildcard at a start, there's pretty much no optimizer that's going to help you there. With full text search, there are some things around that, but basically never run a query with a wildcard at the start of it. There's also some extensions for Postgres Performance. There's PG rowlocks and PG stat tuple that give you various statistic information on it. You can kind of dig into those, but I mean, I think really the more interesting thing is how do you understand really from afar what's going on in your database. It's great if you know this query is bad, but most applications have tens, hundreds of different queries that are regularly running. And how do you know if your database is healthy? Postgres is really good, and don't worry too much about the code that's on here. There's a lot of it, and what's actually there isn't as interesting as kind of the high level of it. Essentially, Postgres keeps frequently accessed data in its hot cache. It's going to keep that in memory for you, and it knows when you access data frequently. So what you want is essentially enough memory for your database so that most of your data is following the 80-20, the 90-10, really in most cases kind of the 99%, 1% rule where it's accessing data from cache. So I'm just going to copy this query actually and come over here and run it. So right here you can see I've got a cache hit rate of 92%, an index hit rate of 91. It's on my laptop, so I'm not too worried about that. You can also get a more detailed breakdown of index hit rate. So running this query will give you index hit rate that looks like this. And what this is going to show is the rows in the table and the percent used. And rough guidelines for these, I would say you want your cache hit rate to be around 99%. If it's not, add more memory to your box. Databases scale up really well. It kind of works for them. You don't have to shard when you have 100 megabytes of data. Index hit rate, 95, 99% is always good. And index is really on anything that's kind of 10,000 rows or better. So I mean, in this case, I would take everything from rollouts up and basically go back and add indexes to it, just to see that the percent of time that the index is used is increasing like I'd expect. So PG stat statements is another thing in 9.2. 9.2 had a lot of really good features in it. This is very possibly, I think, the best one in there. What it takes is when you turn it on, every single query, it basically normalizes it. So if I'm actually putting in email addresses there, it's normalizing this to email equals question right there. And it's going to track the number of times it's run, how long it takes to run, and all of these other things that I understand some parts of which blocks are read, which ones are dirty, which ones are written to, the difference between shared and logical and all that sort of things. But the interesting thing that you can do with it is run a query like this. And what this query is going to show is across my entire system, what is the total time that this query's been run, what's the average time, and what's the query itself. So basically with this, I can see which queries are the absolute worst on my system, where time's being spent, and optimize this really, really simply. I would start off right here on that second query, whatever it is, and probably take that from 80 milliseconds down to 1 as best I could. And I'm saving, and on the left, actually, it pulls it up in minutes. So I'm going to save, 200 minutes of compute time on my database down to hopefully 20. You can also do some pretty cool things. This is a project that we've got up on GitHub that visualizes a lot of stuff based on PG stat statements. If you're on Postgres 9.2, take a look at it. It's pretty easy to set up and configure. But it overlays a lot of things like lock contention, cache hit, sequential scans, all those sort of things right there for you. And if you're on Heroku, check out PG Extras. Even if you're not on Heroku, take a look at it. All the queries are in the source there. It's a command line plugin, but it'll basically easily show you cache hit, index hit, locks, currently running queries on your database, unused indexes, all these sort of things that you actually care about, but Postgres doesn't make it easy to really get at them. So querying. I'm not going to cover too many of the basics here, more of hopefully the more interesting things. Window functions are something that's been around for a few years, but it still seems like not enough people know about them. Essentially, if you want to aggregate on some subgroup and order it. So if you want to find, I've got an example database here that I'm going to run a query on in a minute. If I want to find my top spender by every state, so I've got their purchases, I've got the state they're in, and I could find the top one by just ordering all of it. But how do I find the top in each state? Window functions make this pretty easy. I can basically rank over some value and then partition by that subgroup. So in this case, I'm going to partition by the Hstore value of state, and I can actually just run this as well. And you can see, like Florida, I've got the #1 person. For New York, I've got 7 people in there, and it's got the order of them, and I can filter on this. So if you're doing any kind of reporting on your data and pulling stuff up into application logic and then doing further manipulation, a window function is probably actually what you want to be able to solve that pretty quickly. There's also a lot of extensions around reporting. Fuzzy string matching is a really fun one. That'll show you how similar 2 strings are. I won't go into this just to potentially save some room if I get through everything for questions. But basically, it'll say, are these things similar, are they not? Do they sound alike, or do they not? So it's a nice kind of quick and dirty spell check if you want to try it. For moving data around, copy is really great. It's really efficient at bulk copying data into or out of your database. But another actually kind of fun solution is dblink. So dblink will let you query from one Postgres database to another and then join across that data. It'll do things like pushing down conditions and all that sort of stuff. So it's actually pretty efficient. Now, I wouldn't pull back your whole database from one data set to another. But when you want to query disparate data, it's actually really good for that. And kind of in that vein, there's something called foreign data wrappers. So foreign data wrappers wrap external data service providers. So things like Oracle, MySQL, even Twitter, which I haven't tried, and I'm not sure what it does. But you can query Twitter from inside Postgres.
What could possibly go wrong?
There's some interesting ones out there. So they're not exactly friendly to set up, but it's not too bad. I've actually set one up locally, and I'm running Redis locally. And once it's there, so before I did DT to describe my tables, if I just do /D, you can see there's a foreign table there called Redis. I can select from that. And it just basically queried to my Redis and returned that in Postgres. I can run a more interesting query on that too and join against that data. So in this case, in Redis, I'm storing like visits every time a user visits the website. I can join this against user IDs and get what is the user ID email of people that have visited at least 50 times. I used to say the Redis one wasn't quite production ready, though actually they've really been working on it. So it's getting a lot better. But if you're doing this in a reporting fashion, it's usually not too bad. CTEs are another thing. Common table expressions, or commonly referred to as with clauses. How many people here like writing SQL? That's entirely too many hands. It's a horrible language. It's incredibly powerful, but it's a horrible language. It's not easy to follow or understand. If you ever looked at somebody else's queries and just like wanted to stab yourself in the eye with a pencil, it's pretty common. CTEs actually make SQL pretty variable and pretty nice. Really, they're kind of like views inside a single query. So you basically say, with whatever, I'm going to name it up here, I have some more complex query inside there, and I can chain these together. And then later, in an actual query at the bottom, I can just reference that above. So it's going to reference the results of that just as if it's any other kind of table that exists for that query. So what you can end up with are 50-line queries, but actually it's understandable by someone that just comes to it. So a few more things. This is a pretty new one, Postgres HyperLog log. if there's any stats people in the room, they may understand what all this is better than I do. It's a k-mean value, bit observable patterns. Basically, it's for storing uniques and big data in a really small data set. So you can store tens of billions of uniques inside a 180 byte data type with a 1% error, essentially. So really efficient at tracking uniques and being able to union across them, group across it, that kind of thing. Basically, it's like any other extension, create extension. You've got your data type, and then you basically add this into that data type. So you have some other value that you want to bucket it by, so if it's date, and then you can roll up in more complicated things. So I can select like a query based on that and basically say, give me the cardinality of my users by date. How many uniques did I have on each date? But then I can also do that across months, so I can extract the month and do that really efficiently without having to do a select distinct across millions and millions of records. This is actually really efficient, and it's just going to aggregate that as you insert data. A few more extras. Listen notify is essentially pub sub inside your database. So it's not uncommon for people to use their database as a queue. It's actually not that bad if you use it without polling. Q Classic is a great library for this. Hopefully there's a few users of it out there instead of delayed job. It's great, it's efficient, and it just kind of works. Per transaction synchronous replication is another nice feature. By default, Postgres' replication is asynchronous, so there's going to be lag there, but if there's things that you care about like purchases, you can make sure those are synchronous, so they can be slower, and you can do it on only that single transaction. So everything else in your replication is asynchronous. So photo uploads you don't care about if they're lost, but purchases you do care about. Select for update is another nice one. A lot of these things are pretty native in Ruby. So full text search, there's a PG search gem. There's a nice upsert gem if you want that functionality that I think uses the CTE. Q Classic for listen notify. SQL is awesome to actually get most of the Postgres functionality. It doesn't try to treat all databases the same. It actually gives support to features when they're there. And essentially, again, this is the TLDR. I think the biggest thing that's, to me, kind of exciting about Postgres right now is the momentum that it's got. The community seems to be growing, including the core community. So things like more and more extensions, more and more flexibility, better JSON support, better support for big data, all these things are rapidly coming in coming years, which I think we've seen kind of that momentum start to build over the past few. All right, thanks.